Hello, welcome to my re-recorded lecture on k-nearest neighbors. So far in this class, we had talked about linear models such as linear regression and logistic regression, and we're learning more about nonlinear models like classification trees and k-nearest neighbors. And so this week, we're going to talk about the mathematical concepts of similarity and distance which underlie k-nearest neighbors methods. And then we'll talk more about the k-nearest neighbors algorithm and learn more about how to avoid overfitting in k-nearest neighbors. So far in predictive modeling, we've talked about linear models, which are trained using maximum likelihood estimation. The end result of such a linear model is called a linear discriminant. It's a line that divides the two predicted classes. And so every time we have a new instance to classify it, we see which side of the linear discriminant it ends up on, and then that will determine whether it's one class or the other. We've also talked a lot about tree models, and now that we've made more progress in the course, you can see how we're using the basic idea of trees to build ensemble methods as well. But the base learner, the basis of a tree-based model, is recursive attribute selection. So we start with the full set of instances and features, and then we recursively find the most important or the most informative remaining feature to split our set of instances into increasingly pure subgroups with respect to the target variable. The decision boundaries for tree-based models are a set of axis parallel rectangles. And so in this figure, we can see these green dotted lines are our classification tree decision boundaries. And so to classify a new instance, we feed it into our tree and then see what check the node where it lands, or check the rectangle where it lands if we're looking at this particular way of visualizing trees. Nearest neighbor models use the idea of similarity instead, so it's a little bit of a different approach to classification. The underlying idea for similarity is that if two instances, for example, people or items or whatever we're trying to classify, share some similarities, they're probably similar in other ways as well. The k-nearest neighbor algorithm predicts the classification of a new instance by combining the y values for the most similar training instances. The idea of similarity is also very useful in unsupervised learning. And when we come back to clustering later in the semester, we'll see similarity come up again. There are lots of applications for similarity and nearest neighbors methods in industry. The most famous one is probably recommender systems. Recommender systems use this idea that I will be likely to purchase or watch or enjoy items that are similar to things that I have purchased in the past, or that I will be likely to purchase or watch or enjoy items that customers who are similar to me have also liked in the past. And so we can see this in the set of Amazon recommendations for cat toys that I bought my cat a long time ago when she was a kitten. It's suggesting these are similar items to things that I've bought for my cat, so I'd probably like them as well. Similarity is also used a lot in image comparison or facial recognition, in information retrieval, sometimes also known as concept search, and also in outlier detection. So there are lots of ways in which similarity is used and applied in the k-nearest neighbors way. The kNN algorithm is what's known as a nonparametric model. So everything else that we've talked about in class is a parametric model. In parametric models, we learn a model or a set of parameters that summarizes the training data. And once we have that model, or once we have that summary, we no longer need the training data to make predictions. So examples of parametric models that we've covered are linear or logistic regression, where the parameters are the set of splits, or the set of coefficients. In classification trees, the parameters are the set of splits that we'll use to divide our training instances. We talked a little bit about SVMs, support vector machines. Those are also linear discriminant models that learn a set of coefficients. Neural networks, which we won't really cover in this class, are also parametric models. And so most of the things we talk about are parametric. kNNs are completely non-parametric, meaning we learn no model, so we don't summarize the training data, but then we need to use the entire training set every time we make a prediction. And kNNs are sometimes also known as lazy learners. We don't learn parameters, we don't learn any model, we just use the training data every time. They're also sometimes called instance-based prediction or instance-based training. But kNNs are non-parametric models. The advantage of non-parametric models is that they're very flexible, so they can really flexibly fit. They don't make a lot of assumptions about the relationship between the x's and the y. The disadvantage there is that non-parametric models are really good at overfitting, and so we have to take careful precautions to avoid overfitting in kNNs. So here's the basic gist of the kNN algorithm. So for each new point that we want to classify, first we find the k most similar neighbors. So we'll need to choose k, and we'll also need to define what we mean by similar. And then we'll combine their y values or their classifications. And then somehow we'll use that combination of the most similar neighbors to determine the classification of the point of interest. So if we look at point B in this figure, we're trying to predict in our same old beer prediction problem whether a person prefers light or regular beer. And person B, if we were going to use 3 nearest neighbors, of its 3 nearest neighbors, 2 of them are light beer drinkers. And so with 3 nearest neighbors, we'd probably predict that person B is a light beer drinker. If we had 5 nearest neighbors, well, 3 of those 5 nearest neighbors are regular beer drinkers, so we'd probably predict that person B is a regular beer drinker. Then if we had 7 nearest neighbors, if we again expand the radius, 5 of those 7 nearest neighbors are regular beer drinkers, so then we'd be really confident in our regular beer drinker classification. Okay, so that's the general idea of k-nearest neighbors, and in the next few lectures, I will get more into the details of how to classify instances with nearest neighbors methods.